Okay, hello everybody. Okay, today in this class we are going to discuss about some introduction regarding mechanics of materials. This subject, that is skill development in competitive examinations. Okay, subject code is P18ME59. Okay, this is one of the important topic in your GATE syllabus. Okay, we know that GATE syllabus we are classified as design stream, production stream and thermal stream. These topics or these subjects, mechanics of materials, comes under design part. Okay, here this mechanics of materials you have studied in your 4th semester of UG, right? In there you have studied some basic concepts, and also you have solved some problems regarding beams, shafts, columns, some mechanical members, machine elements that you have solved, how the stressors are induced when the bodies or the when the components are subjected to external forces, movements. Okay, then different type of stresses induced and strain developed inside the body that you have calculated, and also different elastic constants whatever you are going to use, and basic properties of materials, that is mechanical properties, you have studied. Okay, under this mechanics of materials, here now you can see here it is also referred as a strength of materials, because the mechanics means you know that the mechanism of the material, how it behaves, okay, and what is its strength, then how you are going to express the strength of the material. And mechanism means here what is the behavior of material or the component when it is subjected to external force or movements. Okay, that you are going to study under this mechanics of materials. Here you have to study some basic concepts, that what do you mean by stresses. We know that generally the formula or relation of stress is that is F is equal to, that is sigma is equal to F by A, that is sigma is stress, F by A is force by area, that is only the mathematical equations. Okay, but the general definition of stresses here it is given, it is the intensity of internal resistance. What is that intensity is? Okay, intensity means what? Intensity is nothing but it is here it is given intensity means per unit area. Intensity we are considering for unit area. Intensity is in Kannada we are telling that it is a tivrate. Okay, how it is intense for internal resistance, okay, offered by a body or a material against deformation. The stress is, it is the intensity of the body, it is the intensity of internal resistance of the body or the object when it is subjected to external force. That intensity of internal resistance, or that internal resistance developed due to external force which are applied on the body. Okay, that external resistance will going to reduce the deformation of the body. Okay, if the material or the component having the higher internal resistance means it will going to resist the deformation. Okay, here that is stress is, we are considering this resistance force developed for the applied force per unit area is called as stress. You know what is the unit of stresses? Stress mathematically you can write like this: sigma is equal to F by A. Sigma is equal to F by A. F is in Newton, A is in meter square or centimeter square or millimeter square. Generally we are expressed in terms of Newton per millimeter square or megapascal, that is MPa, megapascals we are using to represent the stress inside the body. That stress you have to if you want to define a stress, you have to explain like this, you have to define like this, that is it is a resistance offered by the body, right? Here it is given, here this rectangular bar is subjected to a external force of P, then you can see that this force is acting perpendicular to this plane. Okay, the area which is resisting this force is, here it is given this hatched portion is, you can see that this is the area which will going to resist the external force P. That resistance is developed here. That resistance is always opposite to the direction of load. In the opposite direction, the force is acting like this, the resistance is opposite to that. Okay, here the force is like this, but resistance is opposite to the applied force P. That resistance per unit area is called as what? Is called as stress. Okay, generally in stress we can see two different stressors, that is normal stress and shear stress. This classification is based on the direction of the applied load, right? Here the resisting force normal to the plane or section per unit area. Here this resisting force is normal to that or perpendicular to this plane, resisting plane or the resisting area, then we can call it as a normal stress. Here this direction is normal to the plane or perpendicular to the plane, so it is normal stress. What is the intensity of resisting force parallel to the section? If here it is normal to the section, the resisting force is normal to the section, we can call it as a normal stress. Okay, or generally we can say it is a stress. The intensity of resisting force, if it is parallel to the section plane is called as shear stress. Here it is perpendicular. If this is parallel to this, like this, if it is acting in this direction or in this direction, if it is parallel to the plane of resistance, then we can say it is a shear stress. Here you can see that what is that normal stress is. Normal stress, we can say that it is F by A, it is average stress. It is also we can represent this as P by A, that is load by unit area. This average stress can be assumed to be the stress at any point on the plane, right? Here this why you are using this average, sigma average is, this stress value is same. You can in everywhere, if you are considering any point on the plane, okay, point on the plane, if resisting force is uniform throughout the plane. If resistance is not uniform, then stress at any point on the section can be defined as it is delta F by delta I. It is for a point, it is for a plane. Okay, then it is delta F by change in force by change in area. Okay, originally we are considering it is area. If it is a rectangular, it is length into breadth of the rectangular section. But here it is, you have to consider the change in area, that is dF by dA, that is for a normal stress. Here it is a normal stress because this resistance area is perpendicular to the load, applied load. What is a shear stress means? Shear stress is a resisting force is parallel to the plane. Is here we have a rivet. Here we have a rivet. These two plates are connected by the rivet at the end. Okay, here this plate is subjected to external force of P and this plate is also subjected to external force of P. Here these two forces are acting in the opposite direction. One is acting in the leftward direction, another one is acting in the rightward direction. Due to this force, due to these forces, applied forces, this section of the rivet will going to tear off. Okay, here this force is resisted by this external force, this P, this force P and this force P is resisted by this section of the circular section of the rivet. Okay, here you can see that this force P we can transmit on this section and we can transmit on this section. This is the portion or this is the section of the rivet which will going to resist the external force P. Okay, when this force exceeds when it exceeds the resistance of the rivet, what happens? There will be a separation of these parts will takes place. This rivet will separate into two parts like this. Okay, the same part here also you can expect, but this resistance is Q, it is always acting opposite to this direction. But here you can see that this resistance is parallel to the applied force P. In this case we can say it is a shear stress. In a shear stress, resisting force is parallel to the resisting plane, and also force line of action of the force is parallel to the resisting plane. The shear stress is also load by area, that is Q, or Q it is also equal to P, because for equilibrium condition the P is also equal to Q. Is equilibrium sigma F is equal to 0. For this case you can see that minus P plus Q. Okay, minus P, it is acting opposite to the direction of the resistance, it is a minus, plus Q is equal to 0 for equilibrium. Then if you are simplifying like this, P is equal to Q, then you can see that shear stress is load by area. Okay, you can also take this load is also equal to the resistance force developed inside the body for the applied force. Then you can say it is a resistance for unit area or external force which is acting on the section. Also you can consider that. You can consider that the unit of stress is Newton per meter square, similar to unit of pressure. Here 1 megapascals, it is equal to 1 into 10 to the power of 6 Newton per meter square. You know that a mega is equal to 6. Mega is 6. 1 into 10 to the power of 6 Newton per meter square. If you are converting into Newton per millimeter square, this is 1 Newton per millimeter square. Okay. If you are converting this into Newton per millimeter square, you have to divide it by 1000 into 1000. Okay, that is 10 power 6. This 10 power 6 and this 10 power 6 will get cancelled. The remaining is 1. That is also equal to 1 Newton per millimeter square. Then these two, you can, without any conversion, you can use 1 megapascals is equal to 1 Newton per millimeter square. Okay. Next, you have some constants here. That is Poisson's ratio. Poisson's ratio is nothing but it is the ratio of lateral strain to the longitudinal strain, is a constant quantity and is called as a Poisson's ratio, and is denoted by the letter V, or sometimes it is denoted by 1 by m. What is a lateral strain? Is strain developed in a lateral direction. Here you can see that it is a longitudinal length, along the length which there will be a force P is acting. This delta is change in length along the longitudinal direction. If there is any diameter or this section dimension will get changed, that we can call as this dimension or this direction is a lateral direction. The strain or this diameter will get reduced or increased. That dimension changes, we can call it as a lateral strain. It is if it is changes along the length, it is a longitudinal strain. For the most metals, its value is between 0.25 to 0.33. Cement, concrete, it is 0.15. For rubber, 0.5. The maximum Poisson's ratio we can expect only in the rubber. You can stretch as far as possible. We will that dimension will get reduced. Okay, but steel is having 0.3. Right. Okay, next remaining topics, the strain, different types of strains we can discuss in the next class.